Example 3, a 4-pound weight stretches a spring 6 inches. Again, the initial stretch is 6 inches, which is half of a foot. The weight is pushed 2 inches above the equilibrium position. We agreed if you go up, it's negative. So x of 0 is multiplied by, or divided by 12, I should say. That is negative 1/6 of a foot. We need that information. And released. And released. So that means x prime of 0 is 0. It mustn't give an initial velocity. Now, the motion of the weight of function. Find the motion given the damping force. So the damping force is 1/12. The velocity is equal to 1/12 the velocity per. Okay, 1/12. And let me check. They didn't say anything about external force, so we know that mx double prime plus bx prime plus fx equal as 0. Well, let's get m out of the way. So here we say w is mg. So 4 equal m times 32. Divide by 32 both sides. That will be 1/8. B is given to be 1/12 plus F. If I take, let me see, what color did yeah, let's go black. So I know at F equal Kx, the force is 4 pounds. K is what I'm looking for, and it stretched the spring half a foot. So K is 8. I've been putting F, no? Did I put F up there? No, Kx, right? And here, Kx. K is right there. And we agreed 8 was, and here again, we need to clear the fractions to really get x double prime plus, if I multiply by 8, I look at 8/12 divided by 4, that's a 2/3x prime plus 64 x equal to 0. There's my equation. And how does this work? I let y equal e, I let x equal e to the dt. So I'm looking at d squared plus 2/3 d plus 64 x equaling to 0. That means d squared plus 2/3 d plus a number equal negative 64 plus a number, because x cannot equal 0, that's meaningless. Take half of the middle number, which is 1/3, and square it. The numbers are not going to work out to be very nice. That is d plus 1/3 squared equaling, and here the LCD is a 9. I'm going to get 9 times 64. That is negative 576 plus 1. So this is what I'm getting. I'm getting d to equal negative 1/3 plus or minus the square root of 575 divided by 3j. So my solution set is e to the negative t/3, the cosine, and 575 is 5, that's a 115. and that is 5 divides 10 two times. So that's 25. That's 5 radical 23, if I'm not mistaken. 5 radical 23 over 3t, and e to the negative t over 3. Of course, you don't need to write that down. I'm just writing this down to make this simpler on you. So my general solution now is x of t equal c sub 1 e to the negative t over 3. Now, they do that sometimes. You could do it too. It's up to you. You could say it's going to equal e to the negative t over 3 times c sub 1, the cosine of 5 radical 23 over 3t, plus c sub 2, the sine of 5 radical 23 over 3t. Because of the damping force, you could tell that the limit as t approaches infinity, the exponential is going to dominate and zero those out. That's something that you will be looking for in applications. What's going to happen in the long run? Well, let's use the initial conditions. We know that x of 0 is e to the 0, which is 1, c sub 1 times 1 plus 0, and that equals negative 1/6. That indicates that c sub 1 equals negative 1 over 6. So this is negative 1 over 6. Now, if we start paying a bit more attention to the derivative, that is, when I take a derivative, remember I'm evaluating those at 0 every time. The derivative is going to be the product rule. Derivative of the first times negative 1/6, the cosine of 5 radical 23 over 3t, plus c sub 2, the sine of 5 radical 23 over 3t, plus e to the negative t over 3 times. If I take a derivative of this, shouldn't that give me a sign? So I'm going to write it out. Negative 1/6, positive actually, times 5 radical 23 over 3 times the sine of 5 radical 23 over 3t. But when I put 0, isn't that going to be 0? So if I'm comfortable with that, I could skip that part. Plus 5 radical 23 over 3 c sub 2, the cosine of 5 radical 23 over 3t. Alright. Now what? If I put 0 in, if I say x, okay, I'm going to move that a bit to the left as well. X prime of 0, we know that's 0. Well, that is negative 1/3 times, that's a 1, negative 1/6, that's a 0, plus e to the 0 is 1, sine of 0 is 0, plus 5 radical 23 over 3c sub 2 times 1, and that equals a 0. So what does that mean? That means 1/18 plus 5 radical 23 over 3c sub 2 equals 0. That would mean that is, if I clear the fractions, 1 plus 6 times, right, 3 divides 18 6 times, 30 radical 23 c sub 2 equals 0. That means c sub 2 is going to equal negative 1 over 30 radical 23, or that is negative radical 23 over 30 times 23, which is negative radical 23, and 3 times 3 is 9, 690. So again, the numbers are working out really messy because I made this up. The numbers in the book, I'm not going to say they're going to work to be all integers, but only maybe one as messy as this. And if I made an error, arithmetic error, it's the process that counts. Make sure that you're keeping up with what we're doing. And it's the same thing over and over. This is the only application we're going to focus on. And of course, lastly, so this is matching 12.1, 12.2, 12.3, and 12.4, pretty much. Except we're using complex solutions every time. Last example is the nicest of them. We leave the nicest things to last. So I'm looking at this problem, and here we say a 4-pound, that's the weight, stretches a spring 6 inches. So we know that the initial L is, or X is 6 inches, which is half a foot. I need this for two unknowns. So I already know I need it for mass and I need it for K. Well, the weight is pushed 4 inches below. 4 inches is 1/3 of a foot, and it's positive because it's below. And released, x prime of 0 is 0. That's pretty good. Find the motion. All right, well, the motion is described by mx double prime plus bx prime plus kx equal f of t. Did I put that up there, or did I put f of x? F of t. Because it's all a function of t. My mistake. Yeah, that's why I put it f of t in the initial. I should have put made everything in t, but I just didn't want to confuse you in case you read the book. So there's the equation. Alright, what do I need? I need to know what m is. Well, alright, here we go. W equal mg, which means, where's the 4? 4 equal m times 32, so m is 1/8. Got it. And did they say anything about a damping? They didn't say anything about a damping, so that's pretty good. That's a 0, there's nothing there. And then what? We look for k. We know that F equal kx. Well, the force is 4 pounds. The stretch was half a foot. So k equal 8. And we have an external force of 1/2 the sine of 2d. Alright, how does that work? Well, I clear the fractions. X double prime plus 64x must equal 4 the sine of 2t. That is my standard equation. We let x equal e to the dt, x prime, well, you know how to drill, right? So that gives me a d squared plus 64d plus 64 x equal 4 the sine of 2t. Well, we have a particular and a complementary solution. So here we go. We start with the complementary. The complementary, we say x double prime plus 64x equal to 0, which means d equal plus or minus 8j. So x equal c sub 1 the cosine of 8t plus c sub 2 the sine of 8t plus the particular. The particular has a 4 sine of t, so that's going to be a the particular is going to be a the cosine of 2t plus b the sine of 2t. And what do we know here? Well, we know we're going to take two derivatives. Negative 2a the sine of 2t plus 2b the cosine of 2t, and a second derivative, negative 4a the cosine of 2t minus 4b the sine of 2t. And what do we know? We know if we take x double prime, negative 4a the cosine of 2t minus 4b the sine of 2t plus 64 times x plus 64 a the cosine of 2t plus 64 b the sine of 2t. Oh, I love it when that happens. That's going to equal all of that that's going to equal 4 the sine of 2t. So if I take the cosine of 2t, that's negative 4a plus 64a. Oh, that's nice. That's actually 60a. Plus, and the b is going to be 60b the sine of 2t equal 4 the sine of 2t, which means 60a must equal 0 and 60b must equal a 4. So a equals 0 and b equal 1/15. So this is a 0 and this is 1/15 plus 1/15 the sine of 2t. And there is no way around this. I just got the general solution. I still have to use the two conditions to find C1 and C2. Let's do that. X of 0 equal 1/3. X of 0 equals C sub 1 plus 0 equals 1/3. Got it. So C sub 1 is 1/3. That's very good. X prime equals 0. X prime equals negative 8/3 the sine of 8t plus 8c sub 2 the cosine of 8t plus 2/15 the cosine of 2t. And x prime of 0 is going to be, that's a 0, plus 8c sub 2 plus 2/15, and that equals a 0. So all what I have to do now is say, well, 8c sub 2 equal negative 2/15, and c sub 2 equal negative, when you divide, negative 1/60. So my final answer would be x of t is going to equal 1/3 the cosine of 8t minus 1/60 the sine of 8t plus 1/15 the sine of 2t. That would describe this motion with that additional external force. And that would conclude this section.